Hey guys, it's Vince. Today in this video we're going to be discussing the best practices for building your CNC controller. Now, it seems now at least 3 or 4 times a week I'm answering this question redundantly, whether it be through Skype messaging, whether it be through emails, whether it be through phone consultations. More or less, everybody wants to know what is my general perspective as far as building a CNC controller if you've never done it before. If you've already done it before, hopefully you'll learn something here, because I find myself always learning stuff. I don't care how long I've done this. I'm always willing to learn and listen to ideas. And that being said, I hope many of you will watch this video and gain something out of it, because that's definitely why I'm producing it. So what we've got here is a complete breakdown of the exact system I use, regardless of troubleshooting, regardless of assembling. I find that the troubleshooting aspect is virtually eliminated when you start using these principles that I have here. So let's jump in. First thing I say here is gather and review all required documentation and media required for system assembly. If you didn't receive it for the components or are missing some for certain components you purchased, contact the vendor immediately. Guys, do not sit on this. I've said this so many times, but it seems to come up all the time where potential clients or even my audience will contact me and say, hey, I've got such and such component. Can you help me hook it up? And the issue with that is, first of all, I don't mind supporting or helping anybody. The issue I have is if you naturally purchase from another vendor, you should always go to that vendor first. That vendor was paid and he did his service, and that service is not ended until you actually have a functioning component. Because guys, let me tell you what, if the system is not running, whatever that may be, whether the whole system or the component you purchase, you didn't get what you paid for. You have a paperweight until it's doing what it's supposed to do. Hold them accountable, okay? Always protect yourself wherever you purchase from. If you're buying direct from China, realize the stipulations that come with that. Okay, you're going to have language barriers. Unless you speak fluent Mandarin, odds are you're going to be SOL when you're trying to get, support that potentially will make complete sense. Are you electrically inclined? And when I say that, I'm not talking about wiring your house. I'm talking about electronically inclined, where we're dealing with electronics. It's a little bit different perspective. And the more I go and delve into this, I've dealt with a lot of people that have this crossover attitude where they feel that, their aptitude for wiring, commercial buildings is that of dealing with electronics. And we're in two totally different fields here. So again, I want you guys to understand what you're dealing with. Know immediately the vendors you're working with. And the easiest way to do that is you'll know by the time you purchase a component, you should know immediately the quality of the vendor, and how you'll know is how fast they provide support material. If they provide all the support material you need for that actual piece of hardware or the system you've purchased, you know that they want you to succeed. Okay? If they don't, then it's time for you to become proactive. Contact them immediately. Hey, I need this. I need wiring diagrams. I need manuals. I need to understand this. You jump on them immediately. Immediately. Don't sit on it. Don't wait weeks. Don't wait months. I know you're all very busy, but if there's something missing, jump on them immediately. I pride myself on whoever purchases from me, they get more information than they're most likely going to use. I do that immediately upon purchase. And why I do that? For 2 reasons. First of all, I have to deal with my end of the business. My end of the business never stops. The internet doesn't sleep. Many of you know that. Okay, so I'll get messages all times of night, all time zones. It does not matter. Then on top of that, I'm shipping, receiving, doing all kinds of stuff. So that means the longer I wait, the longer you wait, and the more half-assed job I'll do, which usually leads you to being frustrated, which I don't accept. So again, always hold them accountable. Look for the required documentation immediately. If they provide you all the documentation, it is then your responsibility to study all provided reference documents provided with strict attention to detail. That doesn't mean you should be coming home from work after working 10, 12 hours and starting to build the system. I know you get excited. I've been down that road, and that's the worst thing you can do, because once you start assembling the system and you realize you're tired, you're starting to fall asleep, or your attention is just not where it should be, you want to be in a quiet room, or at least I would want to be in a quiet room, and you want to have rest, and you want to be able to sit down and picture what you are trying to do in your mind and then walk through it. Again, using these guidelines, I guarantee you the picture you have in your mind, you're able to produce if you go through them step by step. We'll do it together. Okay, next one. Gather all vendor contact information for support requests regarding components. The reason I'm saying this, again, if they've already provided all the support that's required as far as reference documents, if you get all of their contact information, should you have questions on it, you'll know immediately. Do not start reading the documents when you actually receive the components. Do it days before, preferably once you order them or you've done research on them. That's the ideal way. Start studying the documents. Look at it like a test, guys. You're not going to go into, a college exam and not study for it. I mean, that doesn't make sense. You're not going to study for it. Most of us won't that day. You would actually put some time into study, do some research, and then go through and actually, begin the build process. You just spent a lot of money. You're going to be investing some time here. Value it. Take your time and, again, get all of the support information regarding your vendors. And the big thing when you're looking at their support information, if you're supporting a business, then you should send a test email to see response time. Now, you guys can do that regardless, but I put that in there because it's imperative. You have vendors all over the world. You guys are buying components from everywhere, every location in the world, and typically you don't know what the lead time will be on a vendor support request. The best thing you can do upon purchasing your components is send a contact email. Just something, hey, I look forward to working with your company, whatever it may be, just to see how fast they respond. I cannot tell you how frustrating I've seen clients get when they send an email to a typical vendor and it takes them 4 to 5 days to get back with them. Not everybody will respond within 24 hours. I try to do 24. Actually, I try 12. And typically I do. I have a very low failure rate unless, it's a Sunday, very late at night, something like that. But overall, these are things to think about. And like I said, if you're supporting a business, it's imperative. It can put you severely behind. So again, take that into consideration. Test all your received components individually. This means all drives, power supplies, breakout boards, and anything logical, guys. And why I say that is you want to break up your component assembly so that if there is an issue, you can identify it before assembling everything into the controller. Think about it. If you assemble everything into the controller and then you find you have a problem, you have to go through all of those components before you actually isolate the one that's bad. If you test them all prior to installing it, it's more work on the front end, but less work on the back end. And believe me, it pays you off high dividends. Think about what I'm saying. Okay, many of you would not assemble a car where you'd get it all done before testing the engine. That wouldn't make sense. So again, you want to do each component individually, and believe me, that will save you tons of time. As you're testing each component, and I know this is work, but hear me out. As you're testing each component, I highly recommend grabbing a legal pad and writing down, hey, I tested power supply. If you're not planning on finishing the system all in one day, that's okay, that's fine. Document the date it was tested, document everything was good, whatever voltage it may be, and if you pay this attention to detail, I promise you, the system will fly together and you'll have all that information to cross-reference the deeper you get into the build. Think about what I'm saying, I know it'll make sense. Next thing. Make sure you have shielded and double shielded cable, ferrites, EMI filters, because they're all required for all leads carrying signals. I get questions on this all the time. What do I shield? Guys, you shield any wire or lead carrying an actual signal. Anything that's precious to the system as far as control. Those should be shielded because we don't want them talking to one another. If you do it that way, you're golden. And you have to learn a strategy. And the big thing about a strategy is if you're going to use shielded or double shielded cable, you know you've got a shield drain that has to be grounded. Okay? If you know that you have a shield drain that has to be grounded, that means you have to install a ground bar. Do you really want to go through all that? If you use ferrites, where again, there are applications that you can use the ferrites for, you'll have a passive EMI filter, which you don't have to deal with grounding. So again, look towards all the strategies that are available so you can implement the correct strategy for the correct situation. For drives, I like ferrites. Double shielded cable, of course, should be used, or shielded cable at the minimum should be used for any drive actual motor cables. So again, think about that. Think about the strategy of implementing the grounding bar, where you're going to do it, where the ferrites are going to be, and put that, jot it down. Again, you got your legal pad, jot it down, or paint yourself an image, whatever it may be. Take the time to think about it. And I promise you, it will go tremendously easier. When we think about cabling, and I cannot emphasize this enough, many times potential clients or clients will tell me, hey, I need such and such feet of cable. 9 out of 10 times, they're at least a foot short, at least. Always overshoot the runway by 25% on cable. You don't want to go 25%, go 20. But I'm telling you now, when you start running cable through cable chains, the cable chains will eat up distance of cable. You cannot measure it the same way you would typically a straight line of cable. I get a lot of guys that'll do that. An easy way to measure the cable you'll need in a cable chain: get yourself some string, add a fishing lure on the end, whatever it may be, and fish it through the cable chain. Once you're done, pull that string through and then measure the entire length, and it'll give you a very, very good approximation of the length you'll require. Okay? It's all of these, once again, these little tips, I promise you, will make ordering everything. You won't be ordering twice. Nothing sucks worse, and believe me, I've been there, when you're working on a system and you're a foot short on cable or 2 foot short, depends on how much it is. But if the cable is the last entity holding the system up from being assembled, that just totally sucks. So take your time with your cabling, take your time with your strategy, implementing the required proper shielded and double shielded cable, ferrites, EMI filters, so on and so forth, to protect them signals from EMI. Break up each component you're installing into a system subassembly. This assures if an issue is present as you're assembling the system, you're able to quickly troubleshoot the problem to correct it. All right, guys, let's think about this. If you take and test the power supply like I've already identified above, and you know it's good, and then you hook up your drive and you've tested that, because you've tested, like we said above, you're testing each component, you know that's good. You hook up the drive and the power supply and you're golden. Well, then you hook up your e-stop switch. And you know all of a sudden now your drive is not coming out of fault for whatever reason. Well, we know the drive is good, and we know that the power supply is good. Then it's time to identify the switch, because that's the one variable yet that's been introduced into the subsystem that has not yet been checked, other than when you actually introduced it. So you know now, okay, this is the area I need to look at. The thing to realize about assembling your system, and I think that's more unique with CNC, is that you become the technician the day you start assembling it. There is no such thing as becoming, a tech after the fact. Many guys feel that way because they don't use this method when assembling their system, and then all of a sudden they encounter all these little quirks and wonder, why am I having so much frustration? Again, that's why I put this together. I hope it eliminates that, but always realize you are the tech from the beginning. So again, in that little example, power supply's good, drive's good, you introduce an e-stop, you notice drive's not coming out of fault, you're snapping the switch back, still not coming out of fault, it's time to potentially change that switch and see if you notice anything different. In order to also test the switch, you can just eliminate it completely, just create the loop and see if all of a sudden the drive comes out of fault. If it does, you know your switch is bad. Okay, so in that instance, very quick and easy. I wish they all were like that. Many of you know they're not mostly like that. It's usually more tedious. However, practicing this, breaking up each subassembly, you will be golden. Now, as I say that, I'm going to skip here to test all axes motors prior to installing them on your chassis. This assures motor smoothness and axis linearity. Okay, let's think about this for a minute. I cannot tell you how many people have come to me, we're doing a retrofit, typically it's a retrofit, will buy a system and immediately install everything on the system and expect motion to be smooth, which usually it is, but there are instances where there'll be odd noises, and that's when they start troubleshooting. Guys, test the system off. And when I say off the chassis. Never test your motors on the chassis. Test them off. Make sure everything is smooth. Run some air cuts. Act as if the machine is actually cutting. Run everything, test mock. Make sure everything is running good. Honestly, I like to personally run a system for about an hour to two, just to give me a line of stabilization so I know, okay, you know what, right now everything seems good. You know, if I run 2 hours and I know that the system's running fine, the motors, you can check motor temps. Many of you are aware, or I should say some of you are unaware, that NEMA 23s or stepper motors in general get very hot. It's a byproduct of voltage. They get hot enough literally that they can cook eggs. There's videos online about that. Keep that in mind. Stepper motors do not turn off like DC regular motors. They're always pulling amps because they're always providing holding torque in order to lock the axis and hold whatever position we're in with the robot. So keep that in mind. These are things all to familiarize yourself as you're getting involved in CNC, because a lot of these questions come up, and again, it's the faster we can answer the questions and get the education out there, you will become more adept at becoming the ultra tech you need to be with your own system. So again here, as you've broken up all of the components and you've already done the actual subassembly testing, you've already tested all of your axis prior to installing them on the actual chassis. If you're adding, let's say you're starting with a chassis that has already been tested, you know your chassis, you've assembled it with ultra care, you know where everything is, and now you're ready to modify the controller from its base standpoint. Start documenting immediately everything you plan on doing. If you're adding, once again, a new component or components to a proven tested system, i.e. relays, touch plates, spindle, etc., document every change you have to make to support the addition of each new subsystem. Think about it. If you know what works, then you document it. You know that these settings all work, copy the XML, whatever you have to do with mock to give yourself a backup. Whatever change you make, if you notice you have adverse effects, you can always revert back. Okay, you can compare what worked to what didn't work. Be your own tech. A lot of times, many of you will have to, and many of you are going through that now because you're contacting me knowing that the vendors you purchase from are not willing to support the stuff or can't. And that's the truth, and I'm being totally honest with you. Many of them can't because they're just sellers. They're not looking at, you know, providing the ultra experience that you're hoping for where, hey, I'm carrying something, I should be an expert in my field. That's not the case, guys. I mean, I'm being totally honest with you. A lot of times when you see, and I've said this in many videos, you see a vendor carrying in excess of 1,000 components, what's the odds of them mastering all 1,000 components? Just logically. I mean, how many people could do that in their own personal career? I mean, again, I deal with this on a daily basis, and I still refer to user's manual all the time. All the time. I'm not memorizing everything. There's no way I can digest that kind of information. So again, we have to be logical and we have to be open to communication with the people we're dealing with. And vendors should be more open because they know they're taking your money. So again, hold them accountable and make sure that documentation actually is done from beginning to end on assembling the system. Okay, you start assembly, you want to document everything. I tested this, I did this, I'm adding a switch, I'm adding a touch plate, whatever it may be. Then once you go through, okay, I've added a touch plate, these are the changes I've made to mock, test it. Naturally with the system off, you're going to test everything in a dry run. Make sure everything is working. If everything is working, you check diagnostics, you've got the LED lit up on the probe, you know everything is golden. It's time to move on now. And you know now you're ready to actually try it, you know, with the machine active and live. This is when you know you've completed everything. And now you have that full documentation to support all of the changes you made and the addition of the new component. So on the next addition of another component, let's say you add a spindle relay next, you know where you've left off and everything was functioning. I cannot tell you how many people contact me, well, you know what, I've added this component a month ago, it's working great. Now, it stopped working. I don't know what it is. Can't figure it out. Well, we need to backtrack, okay? Odds are problems like that where something's working, then something just immediately stops. There's always a culprit, and it's how good you are and how much time you're willing to invest at becoming a tech. If you document everything from the beginning and all of a sudden stuff stops working and you date it and you put in as much detail as you're supposed to, it's much easier to allocate what that issue may be. I mean, I'm telling you guys, these videos I'm putting out to help you, and I promise you, if you take and make a hard copy or print out these videos in the sense that you're able to take a snapshot, use it to do whatever you need to do. Again, I've got this in a Microsoft Word document. If you message me, I'll put my contact information below. Of course, you know it's always there. If you say you want a copy of it, I'll send it to you, print it out, and you can use this right there alongside the video, whatever it may take, so you know you've got all this information at your hands so you don't forget anything. And I guarantee you the process becomes virtually automatic after the first hour or so. You'll start writing everything down. You'll have documentation. Something comes up, you'll be able to go right through and allocate where to begin. Okay, I'm going to troubleshoot from here and work down. Something weird with my cables. I'm having, intermittent. My drives only move one way. I've had all kinds of weird things, and usually it's the time it takes for you to actually go through and look at wiring, all the diagrams. I mean, it's a lot of information to digest. As you break them up piece by piece and take your time, I promise you, it will become second nature on how to break it up, and you'll know, okay, one step, next step. Individual drive systems, you guys are going to have the toughest time because there's a lot more wiring going on. Integrated drive systems like a G540, very, very simple, okay? That's one of the reasons I love the G540. It's my flagship, is mainly because of that. It's ultra, ultra simple. Individual drives demand more respect, demand more time. Be aware of that. A lot of guys always tell me, contact me. They have no actual reference as far as working with CNC. They've just seen some videos. They've seen what's out there, and they love the idea. Great. And they immediately want to get into a pro drive system where they have to wire each individual drive. That's fine, but realize what you're getting involved with. And when I say that, it really, really does take a lot more time, and it definitely takes a lot more patience. And it's certainly not that you can't do it, but understanding what you're getting into before you get your feet wet, believe me, it saves you time and money, especially if you're looking at getting a system running right away. So again, I hope this video has been extremely helpful. I know it's probably going to raise still some more questions. You guys are probably going to be looking at, things I may have missed. I'm human. I'm expecting that. You can contact me once again directly at storm2313@gmail.com. That's my direct email. Or you can contact me through my eDealer Direct store. Again, I'll put my links in my description below. To all of my subscribers, guys, I love you. I'm working on a lot of stuff right now. Of course, we're coming into peak season, so I've been real busy. I'm going to try to keep the videos coming. If you guys do have questions, once again, or require quotes, message me direct and on either of those two links, and I'll get you handled as soon as possible. Thank you all for your support.